For Unit 7, we're starting a unit on similarity. Similarity is pretty closely related to congruency with some subtle differences. Congruency we talked about back in Unit 4 with congruent triangles. So we're going to start with similar triangles. Figures that are similar, this is our symbol for similar. Our symbol for congruent is this. If we say two figures are similar, we use just that little squiggly above the two lines, okay? Figures that are similar, they have the same shape, but not necessarily the same size. So you look at these two examples, triangle 1 and 2 are similar. They have the same shape, but a different size. But you come over here and look at these two triangles. Triangle 1 is not similar to triangle 3. They're definitely a different shape. They're a different size, which is fine, but they're a different shape, right? You can see in triangle 1, all three angles are acute, and then triangle 3, you have an angle that's almost 90 degrees. So definitely not the same shape. Our formal definition of similar polygons are they're similar if and only if their corresponding angles are congruent. Corresponding angles will have the exact same measure. And remember, corresponding are sides that match to another. We talked about that back when we were introducing congruency, and we'll highlight that again here. And then side lengths that are proportional. Corresponding side lengths are proportional. Okay, and proportional meaning 1 to 2 is a proportion, or 1 to 2 written like this, where one triangle has a side length of 1, its corresponding side length is 2. If we went to another pair of sides, their side lengths were 3 to 6, which is also simplifies down to a proportion of a ratio of 3 to 6. So they're all proportional. They all have the same ratio of their corresponding sides. Okay. All right, let's list some corresponding angles here. Corresponding angles map to each other. So B and F, you can see these are both have one congruent marking on them. So angle B maps to angle F. These are congruent. C and G, angle C is congruent to angle G. And then we'll work our way around using the colors to help us out. D is congruent to H, and A is congruent to E. In similar polygons, and these two polygons are similar, these two quadrilaterals, that's what our marking, similar marking means right here. All the corresponding angles are congruent. Okay, for our proportional side lengths, let's go ahead and pick a pair of sides that are corresponding. So BC to FG. BC to FG. These are corresponding side lengths, and their ratio of their sides is 5.4 to 10.8. Okay. Always reduce these down. 5.4 times 2 is 10.8. So these have a proportion or a ratio of their sides of 1 to 2. Let's check to see if all the other corresponding sides are proportional. Let's do DC to HG. DC to HG has a corresponding side length of 4 to 8, and these also reduce down to 1 to 2. All right, how about another? AD to EH. AD corresponds to EH, and their side lengths are 5 to 10, which is also a ratio of 1 to 2. And then finally, AB and EF, our last pair of corresponding sides. 6 to 12 is also a reduced ratio of 1 to 2. So as you can see, all the side lengths are proportional, all the corresponding angles are congruent. These two polygons are similar. Same shape, but a different size. All right, we're gonna do the same thing down here in these two examples. Let's do We'll do the first example together again. Identify the pairs of congruent angles and the corresponding sides. So for congruent angles, hopefully you can see your two 63-degree angles here. So we can say angle P is congruent to angle R. We can do our 90-degree angles. Angle N is congruent to angle Q. Therefore, our last pair of angles, M and T, need to be congruent. Right. And then for our corresponding sides, all of these ratios are going to be equal to each other, so we're going to write them as ratios, as a fraction. So NP corresponds to QR, NP to QR, which is the same ratio as, let's do our hypotenuse, MP to TR, which is the same ratio of MN to TQ. Okay. If you were then asked to identify what is that similarity ratio, which we're going to talk about on the next page, well, you could just pick any of these lengths, 2.2, whoops, 2.2 to 1.1, which just reduces down to 2 to 1 again. All right, why don't you go ahead and try example B on your own. You don't need to find the ratio of the sides, but I want to see all of the corresponding congruent angles and all of the corresponding proportional sides for B. All right, go ahead. Okay, we're going to work our way around for the angles. C was congruent to K, two congruent markings. B was congruent to J, and D was congruent to L. Didn't really matter there for which side, which angles, because they both are 97. And then A congruent to H. Okay, how about for our sides? AD, we said side AD. Well, AD would pair to HJ. You could have also done the other side to HL, that's fine. AB then would correspond to HL. BC corresponds to JK. And CD corresponds to KL. The ratio of the sides here. Pick any of these sides. For AD, it had a length of 8, and HJ had a length of 12. They were all going to reduce down to 2 to 3 similarity ratio. Okay, and let's go talk about that similarity ratio on the next page. So go ahead and scroll down or flip this over. A similarity ratio is the ratio of the side lengths of the corresponding sides in two similar polygons. Okay, and you can go from one polygon to the other and back and forth. The ratio can be written different ways, so make sure you're reading the directions. The similarity ratio of ABC to DEF. So the smaller to the larger would be 3 to 6. Again, they're all side lengths of 3, all side lengths of 6, which simplifies to 1 to 2. If you were asked for the similarity ratio of DEF to ABC, that would be 6 to 3 or 2 to 1. Always reduce these down. Writing similarity statements is like writing a congruence statement. List the corresponding vertices in the same order. So that would look like this. Triangle ABC is similar to triangle, and all of the angles are the same, so it really doesn't matter where you list them here. Triangle FED, they're all congruent. You could have said DEF. Because everything's the same there, it does not matter the order. If they were different, if the angles were different, then you would need to make sure you write the vertices or the angles in the correct order. All right, plenty of examples here. We're not going to list the corresponding parts. We're going to determine if the polygons are similar. Remember, they're similar if two things. Corresponding angles are congruent. and corresponding sides are proportional, meaning they all have the same ratio. Corresponding sides, gotta check for both, are proportional. If only one of them is true, then these are not similar polygons. If they are similar, write the similarity ratio just like we did up here with 1 to 2 or 2 to 1. Okay, let's do the first example together. You can assume, if nothing's marked in your angles, that these are two rectangles. Therefore, all of the angles are 90 in both. You can assume that's fine. Okay, so our first part's true. All of the corresponding angles, they're congruent. For the corresponding sides being proportional, well, let's check. BC maps to FG, so 9 to 6, which reduces down to 3 to 2. And then let's check this side. BA to FE, 6 over 4, also reduces down to 3 to 2. So yes, these are. The similarity ratio is 3 to 2. And let's write the similarity statement. A, B, C, D is similar to E, F, G, H. Okay. Just make sure the sides are in correct order, right? So if I listed AB right here, AB, it's in the same position as EF or FE. Okay. Maybe one more. Let's do B. Let's do this triangle together. Okay. If you have two congruent angles, then you know the third angle is congruent, right? So angle L, yeah, these are all, it checks off, right? We have one corresponding angle, two, and then we know the third is also congruent because of your third angles theorem. Now let's check the sides. Let's check the ratio of the sides. Let's do the hypotenuse first. 75 to 30. 75 to 30. Reduce this down. I think 15 goes into both. 15 goes into 30 2 times. It goes into 75 5 times. How about this length that we know for sure, the congruent angle and the 90-degree angle? That would be 60 to 24. Let's reduce these both down. I believe we could do 6 for sure. So 6 goes into 60 10 times. It goes into 24 4 times. Oh, let's keep going down even more. 5 to 2. Okay, so far so good. Let's check our last side, which would be 45 to 24. Or sorry, not 45 to 24. 45 to 18. Let's see, we can use definitely 3 here. So 15, 3 goes into 45 15 times. It goes into 18 6 times. And we can keep reducing down again. 3 goes into 15 5 times. It goes into 6 2 times. All of these have a similarity ratio of 5 to 2. So these are similar. So we would say triangle. LMJ is similar to, if you start with L, you need to start with P, P, N, S. All right, you have these last 2 examples to try on your own, starting with C. Determine if they are similar. If they are, what's the similarity ratio? And then write the statement. Go ahead. For C, yes, these were similar. If these angles are congruent, then you know the angles on the other side were also going to be corresponding and congruent. The ratio was 7 to 5, and one similarity statement could have been, yours could have had a different order, but just make sure that your vertices are in the same order. So E should line up to U, G should line up to W, but quadrilateral HEFG is similar to TUVW. Let's make that more look like a U. There we go. All right. And then for D, yes, these were also similar. The ratio of the sides was 2 to 1. okay? You needed to know that because these two sides are congruent, these two angles were congruent, so these were going to both be 62. That is something you know is for sure with isosceles triangles. And then again, if these two sides are congruent, that means this is also 62, and you could find this last angle by adding 62 and 62 and subtracting from 180. Your similarity statement, triangle QRP is similar to triangle TWS. 2 to 1 was your ratio. 7 to 5 here, 5 to 2 here. All right, and then finally, you might be given similar triangles or polygons and asked to find some side lengths here, and you would just set up a proportion. If they're similar, then their corresponding sides are going to be proportional. So we know that MN, well, let's not use MN because there's no lengths that are given. Let's use NP. We know that NP corresponds to YZ, so we could say 4x minus 10 over 75 is going to be the same ratio as MP to XZ, x plus 5 to 30. And then any time you have a ratio, which is a proportion, which is two ratios equal to each other, you can just cross multiply. 75 times x plus 5, 75x plus 375 equals 30 times 4x minus 10, 120x minus 300. Let's solve here. Let's add our 300 to the other side. 75x plus 675 equals 120x. Move our 75x over. Get 45x equals 675. 45 goes in 15 times. And you were just solving for x, so you're done right there, okay? Remember, if polygons are similar, their corresponding sides are proportional, and corresponding angles are congruent. That'll help you solve for any missing measures in these problems. All right, probably the most important part of this lesson is right here. Two polygons are similar if and only if their corresponding angles are congruent and corresponding sides are proportional.